Everyone, please be on mute. Raveen. Okay. So ductable split. Before going to discuss on ductable split, we'll discuss on non-ductable split. Suppose this is room 1, room 2, room 3, room 4, room 5, and room 6. So we have a concept like this we have given. Okay. Now here basically any project if it is non-ductable split, the type of indoor unit is completely dependent on the client. Client defines the type of indoor unit. Okay. Wall mounted, cassette type. If the capacity, if the room requires 1.5 tr, we take 1.5 tr of indoor and 1.5 tr of outdoor unit. So here I am taking floor mounted of 2 tr and outdoor unit of 2 tr. Here hide away of 1 tr, outdoor unit hide away. Cassette and ceiling suspended. We have indoor and outdoor units. The indoor and outdoor are connected by using a copper tubes as discussed yesterday, right? We discussed this point or not?
Yes, sir.
Okay, so these are the indoor and outdoor units. Now this is non-ductable split, but when you come to the ductable split have one indoor and one outdoor only. We have one indoor and one outdoor only. But what happen is we connect all the rooms by using a duct. We connect all the rooms by using a duct. So why? Because sometimes we know we may not have a possibility of placing this many outdoor units. Okay. Sometimes if it is in the, suppose if the building is 15th floor, 15 floors, and it will be in the 10th floor. 10th floor में इतना outdoor units लगा सकता है क्या हमें? 10th floor में इतना outdoor units हमें लगा सकता है क्या? Is it possible?
No, it's very difficult.
So अभी तभी हमें क्या करता है, वन इंडोर वन आउटडोर लगा के हमें चलता है. So I'm taking indoor of 2 plus 1.5 plus 1, 3.5, 4.5, 6.5, 7, 8, 9, 10 TR. 10 TR of indoor unit and 10 TR of outdoor unit. From here, we supply the air by using a duct. What is duct? Duct is a passage for the flow of fluids. Sorry, for the flow of air. Duct is a passage for the flow of air. Okay. So these are the ducts. Now we need to have a terminals for each and every room. So now, as these are the terminals, now the air here, this is the capacity. Now here we are supplying the quantity of air. Okay, we are supplying the quantity of air. So now for each room, how much quantity of air you need to supply? So we go with a principle called 1 TR is equals to 400 CFM. So as we need 1 TR equals to 400 CFM. Suppose मैं इधर से एक 4000 CFM सप्लाई कर रहा हूँ. ये 4000 CFM ऐसे जा रहे हैं. So पूरा ये रूम पे भी जा सकता है, नहीं तो इस पे भी जा सकता है. Will it reach to this point? No, right? It will not reach to this point, right? So to control the flow of air, what is the device we use? We use a device called VCD, volume control damper. What is the use of VCD? To control the flow of air. So this is roof. Hmm. This is false ceiling. Okay, this is false ceiling. So here the space between roof and false ceiling, the space between roof and false ceiling is plenum space or attic space. ATTIC. So here plenum space or attic space is used to run all the services, okay, like MEP services, HVAC, electrical, plumbing, firefighting, CCTV, okay, security alarms, internet, all the services we use the plenum space. Okay, here ducting also is done in the plenum space. Okay. So can we place it on the false ceiling? No, right? So what we do is we hang this. Okay. Like this we hang by using a threaded rod and angle channel. So these are the terminals, air terminals. So these air terminals are connected by using a flexible duct. Here also we will be having a VCD. Why we need to connect the duct with terminal with flexible duct? Why we need to connect the terminal with flexible duct?
To have compression and expansion properties.
To have compression and expansion. Still any others? When we are hanging the duct network, उसके हाई वेलोसिटी एयर फ्लो होता रहेगा. Whenever the air is flowing, it creates some vibrations. If that vibrations reaches to the terminal, it may damage the false ceiling, right? वो false ceiling को डैमेज कर सकते हैं. इसीलिए हमें हमें क्या करता है, to reduce the damage, we connect with flexible duct to absorb the vibrations which comes from the duct. Suppose हमको कुछ प्रोजेक्ट्स में false ceilings नहीं होता है, ठीक है, तब हमें फ्लेक्सिबल डक्ट का यूज नहीं करता, सीधा हमें डक्ट से ही कनेक्ट होता है. ओके, होप दिस पॉइंट इज क्लियर.
Sir, can you repeat the last point once again? Last one.
डक्ट से कुछ भी वाइब्रेशंस आता है ना,
Yes, sir.
वो वाइब्रेशंस अब्सॉर्ब करने के लिए हमें फ्लेक्सिबल डक्ट का यूज करते हैं. कुछ प्रोजेक्ट्स में, ठीक है, कुछ प्रोजेक्ट्स में क्या होता है ना, फॉल सीलिंग नहीं होता है, ठीक है, ऐसा प्रोजेक्ट्स में हमें फ्लेक्सिबल डक्ट का यूज करने का जरूरत नहीं है, सीधा डक्ट से हो सकता है.
Clear, sir.
Sir, here terminal means the diffuser and grill, na?
Anything. It can be anything.
Sir, how to decide duct and grill, flexible duct, fixed duct and flexible duct?
I'm not getting your question, sir. Exactly.
Hello. How to decide flexible duct? Which area need flexible fixed duct and flexible duct? No?
सपोज आपका फॉल सीलिंग होता है तो उधर हमको फ्लेक्सिबल डक्ट का जरूरत है. आपका प्रोजेक्ट में फॉल सीलिंग नहीं होता है तो तब फ्लेक्सिबल डक्ट का लेने का जरूरत नहीं है.
No, some areas are also false ceiling is there, but he fixed the duct, and some area flexible duct. I don't know why. This is the exact reason.
That is what we can say डिजाइन मिस्टेक. फॉल सीलिंग में ये देखो इधर ये वाइब्रेट होके सीधा वो वाइब्रेशंस टर्मिनल तक आ गया, तब आपका फॉल सीलिंग भी वाइब्रेट होगा ना. फॉल सीलिंग वाइब्रेट होता तो प्रॉब्लम क्या है? वो गिर जाने का प्रॉब्लम होगा ना. इट लीड्स टू ए बिग प्रॉब्लम, राइट?
सर मैंने देखा है कि HU से जो डक्ट कनेक्ट होता है ना मेन, तो उसको फिक्स ये लोग रखते हैं, और बाकी के HCU से कनेक्ट है तो उसको फ्लेक्सिबल डक्ट से रखते हैं, ऐसा है.
उधर भी हमें कैनवास क्लॉथ से ही देता है, उधर भी देता है, इधर भी देता है.
नहीं लगा और आज नंदू शाम को लगाना था 7 बजे.
गॉट इट. उधर भी देना है, इधर भी देना है.
ओके सर.
मैं कुछ चीज ऑन रिकॉर्डिंग में नहीं बोल सकता हूँ, ठीक है? आफ्टर द क्लास आई विल टेल यू व्हाट हैपेंस रियली. ओके.
ఫ్లెక్సిబుల్ డాక్టర్ నో క్యాన్వాస్ డాక్టర్ రెండు సేమా సార్?
మోస్ట్లీ సేమ్. So this is roof. This is threaded rod. This is a duct. This is angle channel. This is okay. So this is how we create a platform to install the duct. Okay, to install the duct. This platform I have created here. Okay, clear, right?
ఓకే సార్. ఇది ప్రతి రూమ్ కు VCD కంపల్సరీ సార్?
Room ka nahi kaadu. Yeah, wherever you want to control the flow, there you need VCD.
స్టార్టింగ్ కూడా ఓన్లీ సప్లై కాడ పెట్టుకుని సరిపోతాయి కదా సార్?
సరే, నా దగ్గర ఒక 10 ట్యాప్స్ ఉన్నాయి. 10 ప్లేస్లో నేను ట్యాప్స్ పెట్టాలి. ఓకే, సో ఐ ఓన్లీ యూజ్ ఎ గేట్ వాల్. మీ ఇంట్లో ఒక 5 బాత్రూమ్స్ ఉన్నాయి, 5 బాత్రూమ్స్ కి 5 ట్యాప్స్ ఉన్నాయి. నేను ఓన్లీ గేట్ వాల్ ట్యాంక్ దగ్గర ఫిట్ చేస్తా. ఓకే, విల్ ఇట్ వర్క్ అవుట్?
సార్
రాదు కదా, ఏమైతుంది? ఫ్లో కంట్రోల్ అవ్వాలి కదా.
అవును సార్.
దట్ ఈస్ వాట్ హియర్ యూ నీడ్ టు కంట్రోల్ ద ఫ్లో ఎవ్రీవేర్.
ఓకే సార్.
Yeah, any doubts still here?
Yes sir. Hello.
Yeah,
Hello. Sir, if we use if we don't use the flexible duct, instead of in the starting of the duct we use the canvas here with the connections. Can it may control the noise?
it's here I am not discussing about the noise, I am discussing about the vibrations.
Okay.
Hope you got
So
it.
it can. Yes.
Yes. Still anyone have issues? Sandeep, once check with your mic. Please unmute and speak once, Sandeep.
Sir, kindly show the last sketch which we have drawn.
Yes.
तुम्हें 8 बजे
We'll show Anwar.
Trial version.
Okay.
Yes, who is speaking?
सर जैसे
Trial
आपने
version.
एग्जांपल हमें दिया
हाँ.
फॉल सीलिंग के ऊपर से डक्ट के लिए, तो ये डाउन थ्रो
Trial
होगा मोस्टली,
version.
Yes, down throw होगा.
राइट? समटाइम्स हमें कुछ प्रोजेक्ट्स में ऐसा करना
Trial
होता है कि
version.
हमें वॉल पे डक्ट्स को रन करना होता है और सामने हमें थ्रो देना होता है ग्रिल से।
तभी भी देना है. तभी
Trial
भी
version.
flexible देना है.
अभी भी हमें फ्लेक्सिबल डक्ट ही यूज करनी है क्या वहाँ पे?
देना पड़ेगा.
Trial version.
और जिसको हम टर्मिनोलॉजी में कहते हैं कॉलर्स,
Trial
डक्ट्स के
version.
कॉलर्स,
Yes.
हमारे यहाँ पे डक्ट्स के
Trial
जो
version.
आप फ्लेक्सिबल डक्ट्स की बात कर रहे हैं, वहां पे हम कॉलर्स कहते हैं उसको, तो वो कॉलर्स की जगह हमें फ्लेक्सिबल डक्ट्स यूज
Trial
करने हैं,
version.
राइट?
कॉलर इधर फ्लेक्सिबल डक्ट को भी हमें कॉलर से ही कनेक्ट करना पड़ेगा.
Trial version.
ओके,
Yes.
Trial version. Trial version. Trial version. Trial version. Trial version.
From where I'm getting this?
Trial version. Trial version.
Yeah. Next. Can I proceed to next?
సార్ అది డక్ట్
Yeah.
సార్ డక్ట్ సైజ్ ఒక దగ్గర పెద్దగా ఒక దగ్గర చిన్నగా ఉంది సార్, అది అట్లనే పెడతారా లేకపోతే మొత్తం సేమ్ సైజ్ పెడతారా?
అది నేను నెక్స్ట్ క్లాస్ లో చెప్తా.
ఓకే. ఆ ప్లీనం సైజ్ ఎంత ఉండాలి సార్?
అది కూడా నేను నెక్స్ట్ డిస్కషన్ చేస్తా. దేర్ ఇస్ సార్ట్ ఆఫ్ క్లాసెస్ ఫర్ దట్.
ఓకే సార్.
Okay. Yes. Yes, Mishra. You can unmute and speak.
Yes, sir.
Yes. Tell me. You have raised your hand. Any doubt you have?
No, sir. ये by mistake, sir. This is hand rise.
Okay. Okay. Next. VRV or VRF. So VRV indicates variable refrigerant volume or variable refrigerant flow. Okay, variable refrigerant volume or variable refrigerant flow. So why it is having two names? So in the year of 1980s, 1984, 1982 in around, the first VRV system existing in the market. Okay, they have VRV system which is existing in the market. So that VRV system was introduced by a company called Daikin. Okay, so when Daikin introduced that system and they have taken the patent rights, remaining companies also copied the system and they have renamed it as VRF, variable refrigerant flow. So if anyone is working in the industry, you may get the difference. Only Daikin company machines we call it as VRV and remaining machines we call it as VRF. Okay, am I clear? Am I clear in this? Okay. Next. So how this system works basically? So this system, in this system, what we do is we have indoor units. So cassette type, and we have a wall mounted of 1.5 TR. We have tower type or floor mounted. We have hideaway cassette type, and we have wall mounted. So we have indoor units. Now we have outdoor unit of 10 TR. Now indoor units and outdoor unit are connected with a refrigerant pipe. Refrigerant pipe. Okay, we connect it with a refrigerant pipe. So refrigerant supply and refrigerant return. Okay, so like this VRV system is connected. So now here we are using same refrigerant. We are circulating the refrigerant here instead of air. Okay, so here there are many advantages compared with this. इससे कंपेयर किया तो इसको ज्यादा एडवांटेजेस है, क्योंकि हियर वी हैव इंडिविजुअल रूम कंफर्ट लेवल. एक एक रूम पे एक एक डिफरेंट टेम्परेचर मेंटेन कर सकते हैं. इधर ऐसा नहीं है, कांस्टेंट टेम्परेचर में मेंटेन कर रहे थ्रू आउट द प्रोजेक्ट. So when we can deploy VRV system, you can deploy VRV system when the bigger load, okay, when the bigger load is converted into individual loads. See, here we have a 10 TR project, but each room is having different capacities. But when you have a function hall, like a banquet hall, in the banquet hall, if you deploy VRV system, it is a waste of money. Okay, you can go with a ductable split. So that why? Because there it's a single place where you need to maintain a single temperature 24 or 22. But here every individual who are going to be in these rooms, they need to be a different comfort zones so that we can deploy the VRV system. So how it works, basically VRV system, how it works.
Sir, please again explain the case study of that banquet hall.
Banquet hall, सपोज ये एक ही हॉल होता है, ठीक है. एक ही हॉल पे हमें एक ही टेम्परेचर, पूरा हॉल को हमें एक ही टेम्परेचर मेंटेन करना है, राइट?
यस.
इधर 22 और 24 और 26 डिपेंडिंग. ओके, बट इधर आप वीआरवी सिस्टम को डिप्लॉय किया तो वेस्ट ऑफ मनी. Why? Because even you can maintain the temperature by using the ductable split. But when you come to the project like office में क्या होता है, डिफरेंट कैबिन्स होता है ऐसा, राइट? ऐसा कैबिन्स डिफाइन होता है सपोज. सो ईच कैबिन में आपको डिफरेंट टेम्परेचर चाहिए. सो हियर load is big, but the load is divided into individual loads again. Then you can go with VRV system to maintain the individual comfort levels. compressor. Right here. Right here. Accumulator. So first refrigerant will go from accumulator to, I'll give some color code so that you can understand. Compressor, right? So it will go to the compressor. In the compressor, refrigerant with what happened in the compressor? Tell me the function of compressor. Compressor में क्या होता है?
Compress the vapor refrigerant.
Vapor refrigerant. Volume को compress होता है.
Increases the pressure.
It increases the pressure and
Volume.
Temperature.
Temperature.
it increases the pressure and temperature. Okay. So वो गरम रेफ्रिजरेंट कहाँ जाएगा?
To the expansion wall.
सीधा एक्सपेंशन वाल पे जाएगा.
Condenser.
कहाँ जाएगा?
Condenser.
Condenser.
Oh, sorry. Condenser.
कंडेंसर पे जाएगा. ठीक है. Okay, condenser will throw the cold air onto the coil. वो ठंडा हो जाएगा ना अभी. रेफ्रिजरेंट थोड़ा कूल होगा ना. So refrigerant will become liquid now. Vapor refrigerant will become liquid. So now this refrigerant now fine. So this is expansion valve now. Normally we have expansion valve in outdoor, right? Expansion valve कहाँ पर होता है? Outdoor पे होता है. But here we have expansion valve in the indoor, which is called as electronic expansion valve. EEV, electronic expansion valve. So after expansion क्या होता है रेफ्रिजरेंट को?
It increase the volume and decrease the pressure.
So this is cooling coil now. Evaporator, right?
Okay.
From evaporator, okay. So now it comes back to accumulator. From accumulator it moves. This is the how cycle closes. Clear? Till here it is clear, right? Refrigeration
Yes, sir.
cycle.
Sir, where is evaporator?
Okay.
Okay.
We have multiple evaporators here.
Okay.
Clear now?
Sir, why we use the inverter compressor or normal compressor in VRV?
I'll come.
Okay.
Sir, you people are very much excited, sir. You people allow me time, I'll complete. I'm not super fast like you. Okay. You need to allow me some time to come that. If I have written here, I'll tell you ना.
सर
Okay.
बट आई हैव मुझे लगा कि ये क्वेश्चन शायद इम्पोर्टेंट हो सकता है.
हो सकता है, मैं तो देना है ना आपको, पूरा खत्म तो करना है ना.
Right.
Okay, I'll come. No worries. You give time when I'm closing the session. Then you ask the doubt. When I'm open for the questions, then you ask. Okay. So these are the multiple indoor units. These are the compressors, condenser, evaporator, and expansion valve is here. 4 components आ गए ना. रेफ्रिजरेशन साइकिल का प्राइमरी कंपोनेंट्स क्या है?
Compressor, condenser, evaporator, and accumulator.
4 कंपोनेंट्स तो मिल गए आपको.
Yes, sir.
Yes. Now see. So we have मैं एक generic form बोल रहा हूँ सर. Generic form. Okay. How you can manage this? But what happened to Manideep? Is Manideep on call? Yes. Then what? The message you have given in the group. So you want to mute your system.
Vinod sir.
yes.
ఈఈవి ఫుల్ ఫామ్ ఏంటి సార్ అది?
Electronic expansion valve.
ఓకే ఓకే సార్,
Okay.
థ్యాంక్ యూ.
Now see here, we have 5 indoor units. Each indoor unit capacity is 2 TRs also. How much? 2 TR. Okay, each indoor unit capacity is 2 TR. Now what we are doing is I am telling you a generic form. There is no proof that every system will work like this. Okay, this is a simple explanation how VRV system works. We have a device called VFD. Do you know about VFD? Do you people know about VFD? Anyone?
Yes, sir.
Variable
Yes,
frequency.
drive. VFD.
వేరియబుల్ ఫ్రీక్వెన్సీ డ్రైవ్.
Variable frequency drive. It takes the input from different sources and it gives command to the electronic devices how it needs to work. Okay, वो कैसा चलता है? It takes the input of the electronic expansion valve here. Okay, electronic expansion valve का input लेता है वो. इधर से इलेक्ट्रॉनिक एक्सपेंशन वालों का इनपुट लेता है, ठीक है. इनपुट ले लिया है. अभी क्या इनपुट लिया है? इट हैज टेकन इनपुट दैट द इंडोर यूनिट्स, okay, the indoor units all are working. If all indoor units are working, that means total capacity कितना है?
10 ton.
10 ton. That means VFD क्या करता है? Both compressors को चालू करता है. It makes 2 compressors to work. Okay. Now अभी एक बंदा ये रूम से बाहर चले गया, तब वो क्या करता है? वो एसी को स्विच ऑफ कर देता है ना. ये बंदा चले गया, ये एसी को स्विच ऑफ कर दिया. समझ पे आ रहा है? अभी स्विच ऑफ कर दिया, अभी इलेक्ट्रॉनिक एक्सपेंशन वाल्व तो बंद हो जाएगा.
Yes.
वो थर्मोस्टेट में ऑफ कर दिया. थर्मोस्टेट इज कनेक्टेड टू इलेक्ट्रॉनिक एक्सपेंशन वाल्व. इलेक्ट्रॉनिक एक्सपेंशन वाल्व पूरा एक्सपैंड ही नहीं कर रहे, बंद कर दिया. तब दैट सिग्नल कम्स टू हियर. इधर आने के बाद ये डिसाइड करता है मैं 8 TR के हिसाब से ही काम करना है, ठीक है. 8 TR के हिसाब से काम करना है. ये इन्वर्टर कंप्रेसर का काम चालू होता है. इधर इन्वर्टर कंप्रेसर का काम क्या होता है ना? इन्वर्टर कंप्रेसर उसका स्पीड, ओके, इन्वर्टर कंप्रेसर का स्पीड हमें मैनिपुलेट कर सकते हैं बाय मैनिपुलेटिंग द फ्रीक्वेंसी ऑफ द पावर. हमें साइन वेव, फ्रीक्वेंसी क्या होता है सर? साइन वेव पे होता है ना. ओके, वो साइन वेव, फ्रीक्वेंसी का साइन वेव, ओके, फ्रीक्वेंसी का साइन वेव हमें चेंज किया तो उसको वोल्टेज कम होगा. बेसिकली वेरिएबल फ्रीक्वेंसी ड्राइव भी होता है, वेरिएबल वोल्टेज का चेंज करता है. सो व्हेन यू चेंज द वोल्टेज, आपका स्पीड ऑफ द मोटर चेंजेस. ओके, स्पीड ऑफ द मोटर चेंजेस. 1 minute. ओके, नाउ 8 TR के हिसाब से काम करना पड़ेगा. तो हमें स्पीड को मैनिपुलेट ऐसा करता है, इसका स्पीड कम कर देता है, which can work up to 3 TR only. कितना TR? 3 TR. ये 5 TR का हिसाब से चल रहा है, ये 3 TR के हिसाब से चल रहा है. तब 5 + 3 8 TR हो गया ना. 8 TR तो हो गया ना. Am I clear? अब hold here. I'll come to your point. YouTube. Just it's a small demo representation. You can see this compressor. This is VFD. Okay. So these are the hedges. Frequency of the power. So did you able to notice the speeds, how it is varying?
Yes, sir.
That is how the speeds are varied to reduce the capacities of the compressor. So from 2024, you know that from 2024 March, you are not able to get a normal compressor ACs in India. Do you know that? Only inverter compressor ACs you will get. Okay. Why? Because the difference I'll tell you. See. So to start a motor, you need two types of current, right? हमें एक मोटर को चालू करना है तो दो टाइप ऑफ करंट का जरूरत होता है. ओके, रनिंग करंट, sorry, starting current and running current. You know that?
Yes.
Starting current is nearly around 7 times greater than the running current. Okay, when you want to switch on a fan slowly turn hota hai to achieve its maximum speed. Why? Because to achieve its maximum speed, it needs to drag more and more power to reach that speed. Okay, सेम फैन के अंदर मोटर कैसे चलते, कंप्रेसर के अंदर मोटर भी वैसा ही स्टार्ट होता है. नाउ कभी कभी आप नोटिस किया आपका एसी, if you set the temperature 24 in the room or if you set the temperature 18 in the room, अब डिस्प्ले में 18, 19, 20, 21, 22 रखता है ना.
Yes, sir.
What that mean basically? मैं 18 रख दिया. That means I want air of 18 degrees centigrade. Is it supplying 18 degrees centigrade air?
No.
How many of you say no? How many of you say yes? This is a basic question.
Yes, sir.
I'll come to one person. Wait. विशेष,
Yes, sir.
आपका घर पे एसी पे आप 18 रख दिया रिमोट से.
Right.
वो क्या है? वो 18 क्या है? कभी सोचा है क्या?
18 is the desired temperature which we want in the room.
Yes, very good. 18 is the temperature which you want in the room, not supply temperature of the air, right?
Right.
Everyone clear?
Yes.
Is everyone clear? Anyone have doubts in this?
Yes.
Now,
सर ये VRV VRF में हम लोग जो यूज करते हैं तो VFD यूज होता है.
सर मैं कहाँ पर है, आप किस क्वेश्चन का पूछ रहे हैं? I'll come wait, क्योंकि आप मेरा फ्लो को क्या करते ना, I'll be going in a flow, आप उसको रुक रहे, वो ऐसा रुक दिया तो झटका लग जाएगा, मैं भूल जाता हूँ और फिर वो कॉन्सेप्ट उधर ही रुक जाएगा. ठीक है. 18 degrees centigrade means if I set a room temperature of 18 degrees centigrade, तब क्या होता है? रूम टेम्परेचर 18 चाहिए आपको, सप्लाई टेम्परेचर 18 चाहिए.
रूम टेम्परेचर
18 चाहिए. अभी आपको रूम टेम्परेचर 18 चाहिए. ओके, अभी रूम का टेम्परेचर 18 आ गया, अभी रूम टेम्परेचर 18 नहीं, तब क्या होगा?
Compressor will trip.
कट ऑफ हो जाएगा, ऑफ हो जाएगा.
The normal compressor.
वही कंप्रेसर ऑफ हो जाएगा. ठीक है, ऑफ हो जाएगा. फिर एक 5-10 मिनट के बाद if there is a temperature difference of 2 degrees or 3 degrees depending on the manufacturer, फिर कंप्रेसर ऑन होगा.
Right.
Okay, we have 2 thermostats, we have 1 thermostat. The thermostat will be in the return grill. रिटर्न एयर का ग्रिल होता है ना, उधर एक थर्मोस्टेट होता है, एक टेम्परेचर सेंसर होता है बेसिकली. वो टेम्परेचर सेंसर क्या करेगा, रिटर्न टेम्परेचर का मेजर करता रहेगा. व्हेन रूम टेम्परेचर रीचेस 18 डिग्री सेंटीग्रेड, दैट मींस ग्रिल के पास भी, रिटर्न ग्रिल के पास भी 18 डिग्री सेंटीग्रेड होगा, तब वो ट्रिप करेगा. बट व्हेनेवर इट इंक्रीजेस टू 20 अगेन, फिर क्या करेगा, आपका पीसीबी आपके कंप्रेसर को ऑन करेगा. ठीक है, दिस इज अ प्रोग्राम विच इज कोडेड इन द पीसीबी. नाउ what happens is, if you are switching off every 20 minutes, your compressor off हो रहा है, on हो रहा है, compressor off हो रहा है, on हो रहा है. So उधर पावर कंजम्पशन ज्यादा होगा. ऑलरेडी मैं बोल चुका है, स्टार्टिंग करंट इज 7 times to 8 times मोर देन द रनिंग करंट. इसीलिए हमें क्या कर दिया, इन्वर्टर कंप्रेसर्स को एग्जिस्टेंस, आजकल मार्केट पे इन्वर्टर कंप्रेसर्स चल रहे हैं. इन्वर्टर कंप्रेसर्स क्या करेगा, इन्वर्टर कंप्रेसर्स विल नेवर ऑफ, उसका स्पीड कंट्रोल करके धीरे धीरे चलेगा. 18 वो धीरे धीरे चलता चलता रूम पे 18 ही मेंटेन करेगा. इट विल नॉट स्विच ऑफ, इट विल मेंटेन द 18 इन द रूम. ओके, दैट इज द रीजन यू आर गोइंग टू गेट लेसर पावर बिल्स. फर्स्ट क्या करेगा, वो हाई स्पीड से चलेगा टू ब्रिंग द रूम टेम्परेचर टू 18. कितना फास्ट से वो 18 तक लेके आ सकते हैं, उतना फास्ट उसका स्पीड चलेगा. फिर उसके बाद व्हेन रूम टेम्परेचर केम टू 18, उसका स्पीड कम करके उधर हमें उसको वेरी स्लोली रोटेट कर रहा है, so that you are going to get less power bills. So if you see the normal compressor and inverter converts compressor ka power consumption, there will be 60% less approximately. Clear?
Sir, I have one doubt, sir. The
Yeah.
normal compressor is sometimes is stop, sometimes is running, but this compressor is continuously running. Maybe this life is not more, na? Because continuously running, na? This is the compressor, na? He want
It
to
is
rest,
not continuously running with higher efficiency, right? See,
okay.
you are walking, bro. You are walking. Okay. If you are running continuously, then it creates problem to you. If you are walking slowly, okay, you are not walking very fast, you are walking very slowly, धीरे धीरे चल रहे आप, तब कुछ नहीं होगा ना.
Okay.
You won't run machine for 8 to 9 hours, right?
Yes.
Okay.
Right, sir.
Nothing. Got it?
Yes, sir.
वो हाई स्पीड से नहीं रन हो रहे, धीरे धीरे रन हो रहा है, रन होना नहीं होना, रन होना नहीं होना, ऐसा.
क्योंकि नॉर्मल कंप्रेसर को रेस्ट चाहिए होता है, इसलिए बाकी के ये स्लो हो रहा है. ओके सर.
यस. Yeah, I am clear till here. Yes,
sir.
Muhammad Shabaz, I think so.
मोहम्मद
शहजाज. आप बोलो, अब बोलो आपका क्वेश्चन.
हो गया सर.
हो गया.
సార్ సార్.
ఎస్
సార్, ఒక చిన్న డౌట్. ఇప్పుడు నార్మల్ కంప్రెసర్ ఈజీగా అనేది అంటే ప్రీవియస్ నాకు తెలిసింది, చిన్న డౌట్ ఇది టాపిక్ ఇది. అయితే ఇన్వర్టర్ మోడల్ కంప్రెసర్లు రిపేర్ అవ్వట్లేదు, ఓన్లీ నార్మల్ కంప్రెసర్లే ఈజీగా రిపేర్ అవుతాయి అని చిన్న టాక్ అనేది విన్నా నేను. మరి దాంతో పోల్చుకుంటే నార్మల్
ఇప్పుడు చూడు, నేను ఒక ఎగ్జాంపుల్ చెప్తా. ఒక్క నిమిషం. మనమంతా इनका क्वेश्चन क्या है कि ग्राउंड लेवल पे इन्वर्टर कंप्रेसर्स आर नॉट इजीली रिपेयरेबल एज नॉर्मल कंप्रेसर्स. अंते कदा?
yes sir. అంతే సార్.
Okay, so when I come into the market, Kia launched its vehicles into the market. Okay, so people are not habituated to Kia motors. Okay, so initially the technicians who are on the ground, not the company technicians I'm talking a normal general technicians who are on the ground, it is difficult for them. Why? Because company will not give any training to them, right Akhil?
సార్.
అప్పుడు వాళ్ళకి డిఫికల్ట్ ఉంటుంది కొద్ది రోజులు పైనాక. see, when the TV market, if you know the television, from CRT to we have the TV is evolved into the LEDs, LCDs, OLED, like that. Okay, the people who are repairing the CRT TVs, when it is evolved to the LED or LCD, it is quite difficult for them to repair that at initial stage.
ఓకే సార్.
5 years 6 years బ్యాక్ ఎల్ఈడి ఎల్సిడి టీవీలు రిపేర్ చేయడానికి ఎక్కడో 100 మందిలో ఒక టెక్నీషియనే దొరికేవాడు మనకి. ఎందుకంటే అది డిఫికల్ట్, రాదు, కొత్త ప్రోడక్ట్ మార్కెట్లో. ఇప్పుడు అట్ ప్రెసెంట్ గల్లీకి ఒక టెక్నీషియన్ ఉన్నాడా? అదే ఇన్వర్టర్ కంప్రెసర్స్ తో కూడా ద థింగ్ విత్ ఇన్వర్టర్ కంప్రెసర్స్, ద రియాలిటీ ఇన్ ద మార్కెట్ ఈస్ ద టెక్నీషియన్స్ డోంట్ హ్యావ్ ప్రాపర్ ట్రైనింగ్, దే నీడ్ టు అప్గ్రేడ్ ద స్కిల్స్, దట్స్ ఇట్.
ఇంకొకటి సార్, ఇది ఇన్వర్టర్ అది చౌక్ అవుతే మొత్తం కంప్రెసరే రీప్లేస్ చేసుకోవాలనే టాక్ విన్నా. అంటే నేను టెక్నీషియన్ గా ఉన్నప్పుడు మా సీనియర్
యు నో అబౌట్ డిసి మోటార్స్?
డిసి మోటార్ ఐడియా ఉంది సార్.
డిసి మోటార్ రిపేర్ చేయలేమా?
చేయగలుగుతాం సార్.
ఇన్వర్టర్ కంప్రెసర్ ఇస్ నథింగ్ బట్ డిసి మోటార్, దట్స్ ఇట్.
అంటే చౌక్ గ్యాస్ చౌక్ అవుతే
into that reality I don't know, Akhil. I don't
Okay.
go into that depth.
ఓకే సార్.
Okay.
ఓకే, థ్యాంక్ యూ సార్.
Sir, can we have a question? Hello.
Yeah, tell me.
सर ये जो इन्वर्टर कंप्रेसर है ये सिर्फ स्क्रोल कंप्रेसर्स में होते हैं कि सारे कंप्रेसर्स में इन्वर्टर हो सकता है? टाइप ऑफ कंप्रेसर्स की बात
आजकल स्क्रॉल पे ही मिल रहा है, as per my knowledge. I don't know how it is available in all. आजकल स्क्रॉल पे ही मिल रहा है.
Okay.
Yeah. Okay. Please make a note of this. I'll share you. Please make a note of these drawings.
Sir, this is trying to make.
Yeah.
The drawing not showing, sir. This is a YouTube video picture showing.
Yeah, sorry. You need to tell me, right? Now you check.
Sir, if possible, then can we have this entire layouts in the handouts section, so we can have the.
You'll get that.
Handout.
No, this one.
Yeah. Yes,
this
sir.
one right now it's like a whiteboard I'm drawing here.
Okay.
If you want, you can capture it. No issues.
Sir, you said you will